Understanding the next generation of artificial intelligence requires us to look past abstract code and instead map its architecture to the most complex system we know, human anatomy. The evolution of AI began with isolated tools, mechanical gears, basic chips, and cold expert systems. Moving up the staircase past today's language models leads to a distinct endpoint, a complete digital life, possessing a unified body for sensing and acting. This AI Vitruvian man illustrates an organism where software components coordinate like organs, integrating a brain, heart, and sensory system into a single entity. This structure marks the transition from a traditional chatbot to a biological-style architecture that relies on perception, centralized thought, and a functioning metabolism to adapt. Within the central command, duties are split between two distinct regions. The main brain, powered by models like ChatGPT, handles creative reasoning. The cerebellum, using workflow tools like N8N, acts as the execution manager, breaking those ideas into rigid, step-by-step action plans. The mechanical heart provides the AI with its core objectives and safety boundaries. To the right, the nervous system uses vector databases to provide the agent with a long-term memory, preventing the amnesia common in standard models. Sensory inputs translate the world into data. The visual AI can parse complex industrial blueprints, while the auditory AI acts as a specialized ear, transcribing speech and emotions even in noisy environments. This anatomical map extends from internal processing to the mechanics of interaction, represented by the hands and feet. In this digital organism, the hands operate through APIs and Python code to manage software like Excel or ERP systems. The feet interface with industrial robots and drones to navigate and work within physical spaces. These interconnected systems transform a reasoning model into an entity capable of gathering data, executing multi-step plans, and interacting with both software and physical hardware. A digital body requires constant life support. Data flows like blood between organs. Security protocols act as an immune system to block harmful instructions, and continuous learning functions as a metabolism for growth. Current green eye remains cut off from the physical world because it lacks a nose. Without it, AI cannot understand molecular structures. The smart Dalton hub bridges this gap as an electronic olfactory system, translating chemical signals into data the digital brain can process. While vision allows AI to navigate digital information, chemical perception provides the data necessary to translate physical substances into a format the brain can analyze and eventually engineer. Digitizing matter follows a workflow. A physical sample is analyzed, and the spectral signals are sent to the smart Dalton node to extract chemical components. This creates a digital twin, allowing the AI to conduct molecular experiments entirely within its digital environment. This differentiates a digital human from a digital scientist. A text-based model generates only documents and code, but the digital scientist utilizes its chemical sensory suite to analyze mixtures, discover new materials, and optimize drug formulations, solving material-world problems that vision and text alone cannot. This entire pipeline, from raw measurement to digital experiment, is the core of molecular informatics, a science dedicated to the information representation and computation of complex molecular systems. Building AI as a complete anatomical organism provides the sensory and motor framework needed to engineer the molecular building blocks of our world.